Welcome to The Explainer. Today, we're unpacking a really fascinating real-world botanical mystery from a gardening journal called Notes on Gardening, which was published back on June 24th, 2026. Now, this isn't just some dry scientific paper, right? This is a first-hand account of a real discovery. We're going to look at how a seemingly impossible challenge was solved, not by human intervention, but by the brilliant, hidden architecture of nature itself. We're talking about the secret vegetative power of ferns.
Okay, let's dive right into part one, the fern propagation puzzle.
You know, every great scientific discovery usually starts with a problem, a puzzle that just needs solving. Our gardener, Eng, writes, "Dear Interweb, I have been investigating the propagation of ferns, especially wild ferns, for some time, but without much success." I mean, you can really feel the relatable frustration there, can't ya? Cultivating wild plants is notoriously difficult. Eng had been trying to figure out how to multiply these wild ferns, how to encourage them to spread and grow in a controlled environment, and was just hitting a wall over and over again. So we have a dedicated investigator who is, at least momentarily, completely stumped by nature. But then, boom, the breakthrough happens. Eng makes this sudden eureka moment discovery out in the garden. Despite all those previous failures and the absolute lack of success, one single fern managed to defy the odds. It didn't just survive, it multiplied. It successfully self-propagated. And the culprit behind this miraculous piece of self-replication? A rhizome. Eng actually observed this firsthand, documenting the very mechanism the plant used to essentially bypass the gardener's struggles and just do the job itself. Which brings us to a part two. What is a rhizome? Let's deconstruct the anatomy. So if this biological structure is the key to solving the propagation problem, we really need to completely deconstruct it. Let's look at the strict botanical definition here. A rhizome is a modified, creeping stem that grows horizontally. Now, I want you to hold on to that word for a second. Stem. It's incredibly common to look at a plant, look at the soil line, and just assume everything happening below the ground is a root. But the rhizome defies that expectation entirely. It's actually a stem that has evolved or modified itself to creep along horizontally, often just below or even right at the surface. Now, what's really interesting about this slide is looking at these key traits, because these are what unlock the fern's superpower. As we established, it's a modified stem with a creeping horizontal growth alignment. But the real game changer here? It stores nutrients. Because this horizontal stem acts as a nutrient vault, it serves as an independent energy source. And this directly enables its absolute most important function, vegetative propagation. The plant doesn't necessarily need to rely entirely on other, much slower methods of reproduction. It literally has a creeping battery pack that can generate new plant growth all on its own. It is the fern's ultimate survival engine. Moving on to part three, adventitious roots explained. But wait, if the rhizome is actually a horizontal stem acting as a nutrient vault and a propagation engine, what on earth is happening with the actual roots, right? How is the plant getting the water and minerals it needs to fill that vault in the first place? Well, the answer lies in what botanists call adventitious roots. As our source defines them, these are the actual roots of the fern, but they extend directly from the rhizome itself rather than from a traditional primary root system down at the base of the plant. And this is a really crucial distinction. These roots are emerging from a completely different part of the plant anatomy than what we typically expect. They're just dropping down directly out of that creeping horizontal stem. And this brilliantly illustrates the dynamic going on beneath the soil. You have a profound contrast in motion and purpose here. On the one hand, you have the rhizome, a stem moving outward, horizontally, creeping along to claim new territory and store up energy. On the other hand, you have the adventitious roots, extending vertically downwards from that stem, reaching deep into the soil. It's basically a perfect architectural grid of plant survival. So the crucial point is this highly efficient division of labor. The rhizome's job is entirely about energy and legacy, storing nutrients and propagating vegetatively to create new ferns. It's the pioneer out there claiming space. Meanwhile, the adventitious roots handle the immediate, day-to-day logistics of survival. They physically anchor the fern into the ground so it doesn't just wash away, and they actively absorb the water and minerals required to keep the whole operation alive. Honestly, if you want to understand how ferns conquer a forest floor or, a stubborn gardener's plot, you have to understand this beautiful, highly efficient division of labor. Let's bring it all together in part four, harnessing vegetative power. So, we've deconstructed the anatomy, we understand the science behind it, and now let's return to Eng's journal from June 2026. Because knowing how a plant works is one thing, but applying it, That's where the real magic of gardening happens. Let's move to and see how this builds. Ng writes this exact provocative thought. Perhaps we can explore propagation through this rhizome. I mean, this is the ultimate cliffhanger for a gardener's journal. Ng started out so frustrated by a lack of success with wild ferns. But by stepping back, observing nature, identifying the rhizome, and understanding its function as a nutrient-rich propagating stem, the path forward becomes incredibly clear. Instead of fighting the fern, Ng is now realizing they can actually work with the plant's own biological mechanisms to achieve their goal. As Ng signs off with, "Till the next post, yours truly, Ng," we're left reflecting on this fascinating little micro-mystery. What started as a simple, highly frustrating day in the dirt turned into a literal masterclass on plant anatomy. It kind of makes you wonder, doesn't it? The next time you look at a patch of wild ferns, or really any dense plant life in your own backyard, what hidden, creeping, highly efficient mechanisms are silently working right beneath the surface to conquer the soil? Keep observing, keep questioning, and thanks so much for joining me for this explainer.